In this video, I will present 7 open science practices that I think every researcher should know about and be able to apply, especially if you're in your PhD. I wish I would have learned this during my PhD. Most of these open science practices are quite easy to apply, but they're impossible in many cases to apply in retrospective. So it's better to know beforehand and don't miss out. And at least you know what you're missing out and you can consciously decide whether or not you like to apply them. So there are many lofty and societal reasons why you would want to pursue open science. One is it contributes to reproducible science. This means that the underlying basis that we have for the facts that we try to agree on is more solid. If things are not based on reproducible findings, then the whole core of what we're trying to achieve in science is undermined. Most science is paid for with public money. So isn't it also logical that it should be available to the public? And thirdly, open science practices increase public trust in science. They make it more transparent. And if you'd ask a normal person, non-scientist, whether or not he thinks we're sharing data or we're transparent about how we get to our conclusions, they would usually think that this is how it's done. It makes more sense, so to speak. But in many cases, it's also directly a good efficiency tip for you as a researcher. So there's many practical reasons why you would also want to pursue open science practices. In general, I think it's a good idea to pursue open science, but it was because of certain replication crises and fraud cases that it became top of mind. So as Diederik Stapel, a famous scientist who commit fraud, described it in his book, it's so easy. There's a shortcut to become famous, to become a TED Talk presenter as a scientist, if you know how to fake or generate very interesting, counterintuitive, appealing outcomes. And faking data is relatively easy for a researcher. It's as if there's a cookie jar on your desk and you can take these cookies anytime you'd like. The problem, however, is, of course, that these facts or counterintuitive findings are not based on reality. And hence, you can get a reproducibility crisis, because other researchers cannot reproduce or find out whether it's true what you've done. This obscures or makes it complex to find out what parts of our literature are based on solid grounding, on reality, and what is not. So there's extreme cases like faking data, but there's many questionable research practices that are also addressing or enhancing the reproducibility crisis. One is the file draw problem or publication bias. This is a general tendency for researchers not to submit research that doesn't show significant positive findings. It's also a tendency for journals maybe not to accept those as easily. And there are many researcher degrees of freedom. For example, if you have a certain specific hypothesis as a researcher, you're generally more inclined to find evidence or support for what you're looking for. If the data shows you what you were expecting, you might not take a second look and check whether it's actually correct. While on the other hand, if your data shows something you did not expect, you're more likely to test or check whether you made any flaws or choices during the road that could have been altered. P-hacking is just looking at a lot of variables, and usually if you have enough variables, there will, by statistical rule, always be something significant. If you then leave out what you did not test or did not find as significant and only present the thing that is significant, something that is spurious could then become consolidated as a fact. Slicing means you only use the part of your data that confirms or presents the things you would like to present. And missing data, of course, can be handled in many different ways. You can impute variables for it, or you can, and it doesn't matter that there's always multiple options, but these are so-called researcher degrees of freedom. And basically, this should be decided upfront so that you don't choose whatever is most convenient based on confirmation bias, for example. So let's dive into the 7 practices that I would highly recommend without further ado. Number 7 is a well-known practice, is publishing Open Acces. So most of you know, of course, that it's better to publish something Open Acces because it's available to everyone. The benefits are clear. But what not everyone knows is that there are multiple ways in which you can do this. There are so-called diamond Open Acces journals. Those are Open Acces journals where the researcher doesn't pay and the reader doesn't pay. So this is ideal in a way. Usually these journals are supported by a university or an NGO. There are many Diamond Open Access journals. Be sure to check out which ones are relevant to your field. If there's not a Diamond Open Access journal available and the journal you're eager to publish in only has a paywall, for example, or charges article processing charges, there's the green route. And this is lesser known, but it's a very viable route. It means that you don't pay article processing charges because generally this is paying for something that you've done work for. It's submitting it, but not signing anything that does not allow you to also upload it in a repository. This is possible. This is legally possible. So just make sure that you are not being forced into an unnecessary contract. In most of the contracts that you are offered after publication, this is allowed. And sometimes you just don't have to sign the contract. What it means is the article puts it behind the paywall, but you upload your article in one of the repositories, such as the Open Science Foundation, OSF, or any other repository available within your specific field. Once you've published your article, you'll notice that your inbox, your email box is filled, or maybe it's the spam folder, with all sorts of journals you might never have heard of that offer to publish or float your article within no time. So there's a lot of predatory journals around, and don't get fooled. Don't pay any article processing charges by publishing with them. There's many tools that you can use to check whether a journal is legit or not. There's also a lot of fake conferences. Just use some of the tools that are here in this slide to find out which ones are legit or not. Number 6 is preprints. What does it mean? Well, it basically means that you publish your article without a journal. You just publish it in a repository before it is published in any journal at all. Why would you do it? Well, it solves the whole file drawer problem we mentioned before. Basically, no matter whether it's an interesting outcome, sexy outcome, or whatever, you can just publish it and everybody can find it so that they know what has already been studied and don't repeat whatever you've already done or shown that to be true or untrue. It does not hurt your chances of publication. The publishers grudgingly admit it. So generally, I just think this is a thing that you should do with every paper. I do it with every paper I write. It's also freely available and easy to do on websites such as OSF or SSRN. Depending on your domain, you can have different repositories that you use. If you're scared of getting scooped, this is also a great way to prevent that from happening because everybody can see that you published it at that point in time. Number 5, pre-registration. So one of the problems I mentioned before was the researcher degrees of freedom. If you don't specify beforehand what you're going to do, then you still have so many ways of analyzing your data. In a pre-registration form, you describe your hypothesis and your analytical strategy, how you're going to handle it, and the sample that you are going to try to obtain at least, beforehand, so that you tie your hands, so to speak, and restrict yourself to whatever you have said beforehand that you're going to do. Imagine playing a game of pool and saying beforehand that you're going to try to hit the yellow ball, for example, so that you show that it's not just a circumstantial thing or just a case of luck. It's good to do because this also prevents you from having to please any supervisor or publisher or whatever. You have made your decision to do it in the way and you just keep it at that and you don't have to change anything because the results are not convenient for anybody. Of course, reality can get in the way and this can force you to make changes. Maybe you did not reach the sample you've decided on. On the one hand, you can counter this by describing your pre-registration in a way that shows how you will handle a lack of respondents, for example, so you can have hypotheticals. In this case, I would do that. In this case, I will do this. But in some cases, you will have to change your pre-registration. This is possible. It's not the end of the world. And in some cases, it will actually increase the severity of your testing. When, for example, you find out that your data is nested, people are nested and not independent from each other, you try to use multi-level instead of what you have the analytical strategy you've tried beforehand or described beforehand. This is better because it is more conservative. It improves actually the reliability of your findings. You can just make the changes, add it, and explain why you did it. A good pre-registration is detailed enough. Just saying only like I'm going to do some analyses, of course, will not achieve the aim that you're trying to achieve with this specific goal. Sharing your code, number 4. Why would you do this? Well, others can then see what you've done. They can retrace the steps. It makes it transparent, but it's also great for you because future you can understand still how you've come to your conclusions and what you've done. Research is a longitudinal process. Sometimes it takes years between the start of your research and receiving peer reviews from a journal. And the peer reviewers will want to ask you things that you might have forgotten. So documenting how you have analyzed your data, this is a quantitative thing, is very convenient. It's very good. And if you use R, for example, a program that saves all the steps you've made, you can easily redo your analyses. If, for example, some of your data changed or has to be changed, this doesn't mean that you need to redo everything and click and run all your analysis by manually doing them together. You can just run the script that you've already written. There's many free guides on how to learn programs like R, which is also open source and freely available. I've added a couple of great resources to this slide that you can use. So data management, this is really an underestimated, undervalued part of research. Researchers just don't learn about this during their PhD normally. Maybe you've learned about it because your supervisor is really passionate about it, but a lot of them are not. And it's usually not part of graduate school, but it's so important. I'm leaning with this advice mostly on the wonderful book from Crystal Lewis, Data Management in Large-Scale Education Research. There's a link to her openly available book in this slide. And basically, this means that documenting what you do, how you do it, and documenting it in a way that you can transparently see what you've done later on really helps you. It's a bit of work up front, but it saves so much work in the end. Just look at the tweets that I've added to this slide. I found them through Crystal Lewis. So finding out during writing the discussion section at the end of your research that something in the data is not correct or dubious, you'd have to start all over again. I had this in one project that never led to a published result because we found out that one of the steps made by one of the research assistants in one of the early stages of the data collection was just not transparent. We could not see how it was done, and therefore we could not trust any of the results. So this basically meant that a whole project was canceled and did not lead to any results. It's one of the dramatic things that you can prevent if you have a clear description of how every data will be gathered, how the data is handled, how it is cleaned, so that everybody can see how it is done. This really synthesizes with programs like R, in which all these steps can be saved within the code. You also need metadata, just like a text file or a Word file, in which you describe some things and how some things are named, for example, if that's not clear from the R code itself. Number 2 is sharing your data. So based on research, this is really underappreciated in educational science. Not a lot of educational researchers do it, even though it's such an important strategy for the broader field. It allows other people to use your data, to collaborate with you, to build on whatever you have done. You have tormented students and teachers with questionnaires, observations. Isn't it only fair if every researcher can build on that and use that as efficiently as possible? They will cite it too, so you will get credits for all the work you've done, and it will actually be used and will have meaning for the world. So it's something you definitely want to do, I would say. You can easily share your data through registries like OSF, Figshare, or whatever your university is offering. And if you do it, make sure to do it in line with the FAIR principles. Findable means adding the right keywords, make sure that other people can find it if they're using search engines. Accessible means it's openly available, and it's not something that is only provided if another researcher asks for it. Remember all those times you were looking for a survey, a questionnaire, and you couldn't find it in the articles? That's just a nuisance. Just make it freely available so that you don't have to wait for an email before you make it available to others. Interoperable means preferably use, for example, a CSV file that can be used in any type of software platform instead of using one that only is that you're only able to open with a software that you've paid for. And reusable means that you add the right information so that other people know what the variables mean, how they were collected, so they are able to interpret whatever findings they get from the data. And finally, number 1, registered reports. Basically, this means submitting an article with only an introduction, theory, and method section. The peer reviewers will review it, and if they think it's a relevant question and it's being answered with the right methods, they can conditionally accept it. This means that as a researcher, you're not dependent on the findings. It doesn't matter whether it's significant, because the question and the methods in themselves were decent enough for conditional acceptance. It will be reviewed again, usually, after you finish the paper. Of course, you still have to write a good results section, and the discussion still has to make sense. But it basically means you're less dependent on whether your outcomes are significant or not. So this helps prevent the publication bias matter, but practically, it also means that you get feedback in an early stage of your research. And this is just brilliant, and I would recommend this for every PhD student. So even if you get rejected, you still have great feedback at the start of your research, when you can still change some of those things in your research design or in your approach. That's why I recommend doing this well before starting the study. And there's not a lot of journals that support it. In my field, it's right now, as I know, only learning instruction. But there's also the option of doing it without a journal. So there's a peer community in registered reports, and you can send your registered report to this site. And without cost, some people, great scientists will provide you feedback. You can also, of course, help this platform by signing up as a peer reviewer. And basically, this puts the power to the authors instead of the journals, and you get the feedback that you want. And later on, you can decide whether you want to take it to a journal and to which journal you want to take it. So that concludes my 7 advice tips for open science practices. There's a couple of more things I would like to point out. If you're interested in this topic, I highly recommend listening to Nullius and Verba. It's a podcast. I recommend becoming a member of the open science community. There's all sorts of local chapters that you can enroll in for free. And there's a couple more papers here that are very interesting if you would like to learn more about the topic. Thank you for listening, and hopefully you'll be able to apply these tips at the right time.